remember how to find the least common denominator of rational numbers? Well, if we want to find the least common denominator of two rational numbers, we're looking at the denominators, of course. And so we want to find the least common denominator of 16 and 24. So the first thing we do is we find all of the factors. So 16 is 2 times 8, which is 2 times 4, which is 2 times 2. So 24 is 2 times 12, which is 2 times 6, which is 2 times 3. Okay. So the least common denominator is the product of all of the unique factors, the most number of times they appear. So let me start with 16. I have a factor of 2. So my LCD is going to have a 2. Well, let's see the most number of 2's I have. I have 1, 2, 3, 4 2's here, and 1, 2, 3 2's here. So which is bigger, 4 or 3? 4. So I need 4 2's in my LCD. So then my next factor, that 2 is not unique because I already have it in my LCD. So I'm done with 16. Let me move on to 24. I already have 2, so I don't need that. Okay, 3. That's different. So that's unique. I have 1 3 in 24 and no 3's in 16. So I need at most 1 3. That's the highest number of 3's in either of these numbers. So my least common denominator is going to be 2 times 2 times 2 times 2 times 3. 8 times 3 is 24. So we're going to use the same process for polynomials. Of course, factoring looks a little bit different, that's all. So finding the least common denominator of rational expressions, is first, factor each denominator completely. Second, take the product of each unique factor the most number of times it appears in any of the denominators. So let's find some least common denominators for these pairs of rational expressions. Example A, we are looking for the least common denominator of 6x cubed and 8x to the 5th. So these are only one term. That means I don't have any polynomial factoring to do because there's only one term. So really I'm looking for the least common denominator of 6 and 8. And so I definitely need 1 3. And there's more 2's over here, so 4 2's. And that's it for the numbers. Then I'm going to need a variable, and the least common denominator is the highest exponent. So in this case, there's more x factors in x to the 5th, so that's the most x factors, and I'll need all of those. So then the least common denominator, single term here, is 8 times 3 times x to the 5th. That's the least common denominator for these monomials. Example B, we want to find the least common denominator for a plus 5 and a minus 5. So now we have more than one term. Lock them up into their factors and see if we can factor them any further. So we have an a plus 5 and an a minus 5. Those can't be factored any further, so I need this unique factor that appears at most one time, and this unique factor that appears at most one time. You will agree that those factors are different, right? One has a plus sign, one has a minus sign, so I need both of those unique factors in my LCD. And I'm not going to multiply these together. The whole point of a least common denominator is to get everything into factors, so that is perfect just the way it is. For example C then, I have a monomial and a binomial. So the binomial, I'm going to lock up those factors. Lock up that factor. So I have a y and a y minus 3. So those are, completely factored. I can't do any factoring of the y minus 3 because the exponent of the variable is 1. I know it's done. So I need this unique factor at most one time, and this unique factor at most one time. So my least common denominator will be y times y minus 3. Find the least common denominator for these pairs. Okay, so example A here. I have x minus 4 squared, which is completely factored. If I just want to write that twice, that's fine. And then 3x minus 12, which is more than one term, so lock it up as a factor. And that's not completely factored, right? Because if you look at those two terms, they share a common factor of 3. So let me factor that out, divide from those terms to see what remains. And now that that's completely factored, I can find the least common denominator. So I have a factor of x minus 4. And I have 2 of those factors here, so at most 2, and I only have 1 here, so that's already inside of this LCD. That's good. So then 3 is different. I need that factor as well. So the least common denominator here, I need 1 factor of 3 and 2 factors of x minus 4. That's the least common denominator. Now, example B is interesting. So more than one term, lock them up. And so we have a factor of x minus 4 and a factor of 4 minus x. But if you rearrange these terms so that it's a negative x plus 4, and then you factor out that negative, you'll notice that they both actually are a factor of x minus 4. So we need 1 factor of x minus 4 and 1 factor of a negative 1, or just negative. So be careful with those. If the terms are exactly the same except for the negative sign, like the order is switched in a subtraction, then they're only different by a negative. So we can factor that out. And our LCD will be much smaller than if we just took the product of those two. So it'll be easier to work with instead. So this would be the preferred LCD in that circumstance.